Hey, welcome back to our Algebra 2 series. This is the third part of our functions videos, and we have a difference quotient problems here. Just to review, the difference quotient being f of x plus h minus f of x all over h. This is at the end of the last video, so we're just going to practice a couple of these here. In the first case here, f of x is equal to x squared plus x. So we're going to substitute an x plus h into each of these to get the first part. We're going to subtract f of x. So I tend to put it like as if there are boxes here. The denominator is just h. So in the first case, when we put the x plus h into our function, we end up with x plus h, quantity squared, plus x plus h. And that's in the first box. And in the second box is just f of x. So I'm going to put a parenthesis around that to preserve the x squared plus x. And that's all over h. One of the ideas here is that when we do the difference quotient, our denominator should cancel. So we're going to see if that happens here. This is going to be x squared plus 2xh plus h squared. According to the square of a binomial, that's that part right there, plus x plus h. That's that part right there. And then we've got minus x squared and minus x, and that's this part right here, all over h. You can tell that I'm left-handed. Okay, then we have a couple of things that cancel out. So if we notice here, we've got an x squared that cancels out with the other x squared at the beginning, and there's an x that cancels out right in the middle there with that last one. So if you notice, all of the f of x will end up dropping out in the end, and what we're left with is 2xh plus h. Did I make a mistake there? Yeah. Oh, I'm sorry. I'm sorry. This is supposed to be an h squared. My fault on that one. So that should be an h squared and then plus an h. Sorry, I made a mistake. That's the h and that is the h squared. They're a little bit different. Okay, and then that's all over h. And finally, if we finish this out, we end up with factoring the h in the numerator gives us 2x plus h plus 1, and the denominator is h. And half of you were wondering when I was going to put a square on that h. Answer here at 2x plus h plus 1. And that's the answer for our average rate of change with two untethered points, or 2 points that, we don't know where they are on that particular function. And the next one has a little bit more difficult work because it's fractional, but I'm just going to go ahead and jump right into this one. That's going to have a fraction here with x plus h minus 3 over x plus h minus x minus 3 over x all over h. In this case, I'd like to multiply the top and bottom of this big nasty fraction by um, excuse me, the x and the x plus h. In the denominator, I'm going to multiply as well, but I'm not really going to multiply it. I'm just going to kind of carry it along for a couple of steps because I know that that h will cancel. So it's going to be h times x plus h in the denominator. In the numerator, as I multiply that through, the x plus h will cancel, and I'll be distributing this x into that quantity. So I'm going to do this all at once here. It's going to be x squared plus xh minus 3x. And then as I do that in the second part, I'm going to cancel the x's, and I'll be left with minus x minus 3 times x plus h. Okay, just to keep in mind that we should not be doing craziness like canceling this x plus h with that one over there. That would be nasty. Certainly don't want to do that. Instead, we're going to work this all out. X squared plus xh minus 3x minus, and I'm going to keep this all in a big parentheses, x squared um, plus xh minus 3x minus 3h. I'm just doing FOIL there. hx, x plus h. I'm kind of taking the long way around the barn here because I'm working this out step by step. But that's all right. X squared plus xh minus 3x minus, and as I distribute our negative into all these, x squared minus xh plus 3x plus 3h. Ooh, that is dizzying. Hx, x plus h. All right. We've done all this work, but our goal here, of course, is to try to cancel the h in the denominator. So I notice I have an x squared located here, and one that's going to cancel out right there. I've got a 3x here that's negative and a 3x here that's positive. I also have, in this particular problem, a negative xh and a positive xh, and those drop out as well. So my numerator just becomes 3h, and that's over h times x plus h. And the final solution here, just 3 over x times x plus h. Wish we had known that at the beginning, that it was so easy. So you see two straight difference quotients. That's just like the textbook. Let's move on to another problem. This one is talking about a difference quotient of a different sort. It looks a lot like the difference quotient that we've seen, but notice that we've got a 2 and a t plus 2, so that's much different. Here's our function. Let's see what happens. First of all, we're going to have to put a t plus 2 in to the x there, and this is going to be, in this case, f of t plus 2, or t plus 2 quantity cubed minus 3 times t plus 2 plus 5 minus the function itself, which is x cubed minus 3x plus 5. Oh, excuse me. That is not what we want to do. We want to find minus f of 2. So let me redo that. It's going to be just plugging the number 2 in. So that's 2 cubed minus 3 times 2 plus 5. Sorry about that. All right, and that's over a capital T. So obviously our T is going to cancel in the end, just the T. All right, let's see what happens here. In this particular problem, it looks like we've got a lot of stuff going on. So I think what I'm going to do is try to multiply this all out. And on the side, if we know t plus 2 quantity cubed is going to be like a Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And there it is right there, the third, the cubic of that. So it's going to look like this. It's going to be t cubed plus 3 times t squared times 2 plus 3 times t times 2 squared plus 2 cubed. And that's where we decrease the power of the first term and increase the power of the second term. If you don't get it that way, just do it by hand. It's fine. Minus 3t minus 6 plus 5. And then this last part here, I think I'm just going to calculate that out. That's 8 minus 6 plus 2, or 7. So minus 7. All right, so that looks real nice. This is all over t. Hopefully my t's will all cancel perfectly. Let's give this all a try. So I've got a t cubed. I've got a 6t squared. I've got a 12t. And then I have minus 3t. That comes from right there. Now I have an 8. I have a 5. And 8 and 5 add to 13. And 6 and 7 subtract. That's going to drop everything out. And I have this as my final answer. I've got a t squared plus 6t plus 12. Oops, excuse me. I believe I should have combined those. Well, I'm making a lot of mistakes here on this particular problem, but notice that these two should come together as a 9t. So t cubed plus 6t squared plus 9t. This is such a long video. I'm rushing to try to get it done. So as we see our answer here now, as we cancel the t out, we'll get a t squared plus 6t plus 9. And the t's drop out. So our final answer here, t squared plus 6t plus 9. All right, so that's what we're going to get with that one. We're going to finish this out with one last problem, and that's going to be an average rate of change from tf of t to pf of p for a function that's now quadratic. So this one does not give us the difference quotient, so we have to write it out. This is going to be, I'll go in this direction here. So it's going to look like this, f of p minus f of t all over p minus t. And obviously in this case, we're going to want to cancel that p minus t in our function. 2p squared minus 3p minus 1. Okay, that's going to be my first part. Minus, and now working with the t. 2, I'm going to use a capital T. 2t squared minus 3t minus 1. And that's all in the parentheses because I'm going to distribute that, p minus t there. All right, now we're rolling. This is 2p squared minus 3p minus 1 minus 2t squared plus 3t plus 1 all over p minus t. As we can see here, the 1's are going to drop out, so we're going to be left with the following. 2p squared minus 3p minus 2t squared plus 3t, that's all over p minus t. And we're going to want to group factor this. So I'm going to actually bring my two terms here together. So that's going to be a 2p squared minus t squared minus a 3, bringing the 3p and the 3t together, p minus t. It's all over p minus t. And we've done this before where we factor out that difference of squares on the left side. So on the left side, we're left with p minus t times p plus t. And on the right side, a p minus t. This is over p minus t. Again, we're factoring out this common p minus t out of the numerator. P minus t goes here. What's left is the 2, the p plus t, minus the 3, and that's all over p minus t. Cancel now, and our final solution for this average rate of change or difference quotient, 2p plus 2t minus 3, coming from that final quantity. All right, so you've seen several different variations of the difference quotient and also of the average rate of change problems. Hopefully that'll help you with all of the work coming up in this area.